we pass over to the next presentation, where we shall talk about the usage of the technologies described by Sergey. Peter. It's not only Peter. I have a colleague here, Timur. Timur will begin the presentation. We have a nice title. We wanted to simplify it, but it's rather big. Well, Timur will make an introduction. Yes, Peter and I worked with services and applications in mobile applications, and we shall tell you about this particular service. Actually, Identity Mixer is an IBM service which has been developing from the beginning of the year 2000, and it is already operating in different areas of identification, authentication, authorization, verification. It can be used in loyalty cards, in electronic elections, electronic votings, in electronic cinema halls, online cinema halls. What is interesting about it? The technology minimizes the necessity of personal data disclosure. We use as much data as needed, or as little data is needed. If you want to watch an online movie, you are not obliged to indicate your name, your age, your date of birth, your place of birth. For example, if we demonstrate your personality, if you demonstrate your personality to the service provider, you just have to show your age. They could ask you to send them the passport scan or the birth certificate scan, and your data may go to some people who can do something bad to you. So the service should know that you are an active subscriber and that you are over 16 years old. And that is all, nothing else. A standard service like OpenID couldn't provide security of all personal data. The authorization service can collect data about visiting different web pages, and the service itself, which offers the services, delivers the services, can get your data through user info from OpenID services. And in these 2 points, you can see problems. We don't want anyone else to collect our data in one place if we don't know that. As a result, we use the notion of minimal data disclosure. Here, for example, we build a certain verification token to be used that a person is, for example, over 18 and that his subscription is active. All the rest is not relevant. So we make a query to the resource server. We get a policy of verification, and then what kind of data must be provided? After that, we generate a special token which cannot be linked to a specific name or address, and if the token is properly verified, it is returned to the resource. The main agents used here are the issuance authority, which issues credentials or loyalty cards, your Credential wallet, it may be saved on your mobile phone. Then we save the passport number or some other verifiers. The Credential wallet is the wallet where the verified data is stored. The data is protected. It can be stored in the secure phone repository, or it may be a separate service. The telephone is better because the data is right where you are, inside your personal secure storage. The verifier confirms that you have the right of access to the required resource in accordance with the policies prevailed, current policies. We also have a revocation authority that could publish information about wrong or inactive data, personal data, and that data wouldn't be used for verification. And we have an inspector. An inspector can get exact data for investigation. This data can be encrypted with a
key of the inspector, and then the inspector, in case of investigation, can use its key to get an access to the data directly. No one but the inspector can do that. And so then this is the process, how it's done, how the verification is done. That's about it. Yeah. So now Peter will Peter, take over, please. Next part. Yeah, and I'll take your questions. Okay. Second part. Timur was talking about services and how services work. About specifics, architecture. Yes, he was talking about cats and kittens. But service, as I was saying, so for the first time, 2001, there was a document released, article about VCM, and it was developed by Jan Kamenisch. It was written by Jan Kamenisch. It's not here, I think. Yeah. Okay. Yeah, Anne Jachman. Yeah, but first time they published this research. So they worked on the assumption on some known approach already, but all this beautiful architecture with cats, it has a big drawback. The drawback is that when we try to give something good, just giving the service to someone, and it's a great boon. But when it's not only him, that there's anyone just who revoke, who check, who save, so it will be good for everyone. So in the case of ours, so the user is happy with the browser. So all they have to have is just to make sure that ours dance would work well. That's it, no more than that. But why starting from 2001? So 14 years have passed, and they started talking about it only now. So because the Blue Mix appeared, because we never had it before, and so with the help of which we could help to do this good for both parties. And actually, so the service is open source. Why it was not implemented? One of the reasons why, so you can just go to the repository and see the code. It's academic code. It's impossible to work out. It's so complicated, so you can't use it. So you can put it together, you can describe it, but you can't use it. And that's why the guys from the Zurich lab. And so she could make it. She could make it here. But she participated very actively. So they tried just out of these two technologies to put something operational. And they saw the technology jointly with IBM. Some time ago, they started to develop this technology, but they're open. And so jointly with Netherlands, with the government of Netherlands, and Danish government, and some other state structures, government structures, and also the EU. And so this ABC4 trust under the auspices of the EU was done. So then at the time when it became obvious that we need to somehow help the developers and help the integrators to bring in this service into the providers' homes. So we decided it would be a good idea to write a service for Bluemix, so that a person a provider who makes up his mind to deploy it, so say this, I can write a code on Node.js, select instead of personality size that we couldn't select last time, an identity mixer, connect it, and then use it. That's it. So first it simplifies the integration process. And so you don't have to think about the code because only have to have two endpoints: check credential and release credential. That's it. Period. Easy. And a few words about the architecture. What's important? That's in the event. That's the first question they always ask us. So you are talking about keeping anonymity, security, what they call the credentials, and put them in the IBM cloud, right? Secure. No, that doesn't work that way, because the service task is to to make sure that all the credentials you keep at your place. So that's one of the reasons why it's very easy to convince the corporation. We always say so. There's users who come to you. They all have to keep the credentials, to store credentials with themselves. You don't have to worry about that. So if we remember the scandal with Sony PlayStation, you remember what happened? I talked yesterday with one of the guys from the States, and he say, so there was another scandal with Ashley Madness, whatever. And so you store them at your place. And then if we had a scandal with PSN, PlayStation Network, and these credits would not leak, because they wouldn't be there. On the side of the Blue Mix, we have a certain service. This service keeps a certain list of policies that we're going to check, or a list of policies that I need to roll back a little bit. So even here, let's assume. So a request for a source, right? What we do? Give us a resource with this ID, identifier, a movie theater just sends back verification policy. Verification policy contains information. The user should have a subscription running, and he should be older than 18. So that's it. XML file describes this policy. Period. So when we give it to the client, wallet processes this policy. Then it stores originally issued certificate, a subscription, and the passport is stored there as well, issued by somehow, or I don't know, the police station has issued this passport. So it's stored there. Then the wallet checks that and the current list of credentials meet the requirements of policy of verification, and sends a token, and then he signs and sends a certain token. So then this token is recalculated by the movie theater, and the token sent meets the verification policy, and then he sends him yes, true or false. True or false. That's it. So the access token. That's it. True or false. Sends back. Then. So what you have is here we. So we're not talking about enterprise private cloud when people want to take something outside the firewall. But we're talking about something standard. So we're issuing passports, issuing subscriptions, loyalty stuff, etc. So on the side of the Blue Mix, so we have this list of policies. So then they store a certain list, or they have a certain list of the authorities that can issue these documents, have the right. So there is a list of policies that have the right to do that. To issue those, and then access to this resource, and then all this information is available. And then we go back to the credentials. Eventually, this list of passports and loyalty cards, it's physically in our Android device, physically there, or if there's a service that you trust and it's ready to keep it in the cloud, so then if you trust the cloud, it can be there. So you can store it there, no problem. And so then, in this case, so we just finished developing this Android application reference, which will become open source. We are working on iOS, and we have another application to develop our own web service. and I think that it will be open source again. Soon will be open source. So then the part that is inside Bluemix, the service, contains exclusively public data. So if anyone decides in the company to deploy anything, just introduce it. So no problem, just put it behind the firewall, and then he will talk only to a certain list of issue specific list of credentials and check on them. That's it. But now just they work. Everyone works with everyone. Everybody with everybody. Then verification. So we request the resource. And we question the resource. Then the user recalculates it, signs it by his own token. We question the resource. Then they call it pseudonym. So then, on the basis of the user key, we can issue a number of pseudonyms and some keys that are not related to each other, but we can identify this public key belongs to another private key, but we cannot say that they have only one parent, a common parent like private key. Then we get this presentation policy. So we sign it, and then we send it back. So it recalculates, it takes out the token for the presentation policy, recalculates it, and makes a decision whether to give an access or refuse an access. So then when you issue a service, the same thing. So what we do, we send a query, and so the query for this part is the trickiest, very tricky. So it will come to a government site, and then we fill out a certain document. So then the government needs to check whether that we fill it out correctly with our true name. So when so it could be an office of government services, for example. And so, but what's important is that this is the issuance authority. So then when we query this information, and then the issuance company does the attributes. You sign it by our pseudonym, sends it back credentials. So now we are in the experimental service, and we never had an idea. We were still thinking whether we are going to depart from the experiment level and go someplace else, but we don't want I don't want us to be perceived that it's a way just to learn more about this technology, to play with it, and to attach it to some resources, and to generate some to play with it. So now just it's a play, but I don't want the people to think that this technology is something. So don't take it lightly. So because that's certainly it will be. So it's a. So we'll play with it, experiment with it. We'll get the feedback from the user, and then we'll decide which way to go. Let's see. So you created this service, right? And then there are two choices. You either just issuance body or checking body, monitoring body. So if you're issuance body, so we sign a name. There could be a list of attributes. So here you have name of the company, age, etc. The issuance authority, right? Description of our credential. After we have signed everything, the credential in this form will be stored in our wallet. Nowhere else. If we lose the wallet, the credential is gone. We talk about verification service. You can say. Okay. We can say that the constant attribute age we fill out that we as the issuance authority is SEC 2015 demo. So our credential is a new custom spec and then the age and company name. Here, anyone can verify. Any stand can be a verifier that agrees to give you commercial if it knows that you are older than 18. That's it. Then it says I'll do a new verification policy. I as a source who created the credential will be the SEC 2015 demo. I will say the SEC or pass is SEC or pass spec is this is what but this classification, that's what we talk about. Then we select age in constant 18. That's it. Secker visitor over 18. So this is the policy of checking our credential. Effectively, so the initial codes. It's in April we launched demo, so you can actually go and check. In the mix, demo. So there's a site of the electronic government, and there's a site of another company that we wanted to copy from NetFace, and there's a wallet. And so first you go to electronic government, you get the credential by way of a passport, the name or age you identify, and then you go and get a subscription at the site on the site of the movies, the movie theater, so movies site. Then you go to the movies site, and they say, I want to watch this movie. Then they say, okay, so we have 0, 12, and 18 plus, right? And you can select. I want to see, so 18 plus. Show me your credentials. If you want to watch 18 plus movie, so you show the credentials, and then the system decides whether, so demo is done that way. So whether it's, so the access is granted or not. So in greater detail about the codes, identity mixer, in initial codes, etc. But the Bluemix has a chapter, so then documentation to services, which explains in greater detail about our service, how it works, and how to use it. That's it. Now there's questions. Thank you, Peter. Thank you, Timur. Don't forget to vote with your application. So we have questions, please. You were saying that movie theaters don't know what kind of user is that, but if you buy a movie, so then the movie theater should understand that it's me who bought it, and so it's not that I'm over 18, but that I bought it too. So the movie theater should know that. So then one trick. On one hand, so the companies will be happy they don't store anything, but the marketing department of the company, Google Analytics together, and so they will be unhappy because the amount of personal information so is going down. So the information about users, and so that's a weakness. They want to know more about you, and so then, but who regards it as a weakness? Yeah, that's a drawback. But what we plan to do, so the downside will be less personalized advertising. That's it. And so that's the downside of it. But the user becomes rather anonymous, considerably anonymous, so to operate within some services. Let me show you what it may look like if you buy a movie at the movie theater. So you come with your cell phone, which has your Credential wallet application, which will put your ticket in. So the movie theater will issue to your Credential wallet a unique ID of this movie. You store it, and then it will check through the verifying policy that what's inside conforms to what is required to get an access, to grant an access. And then within our wallet, so there is this passport, and that you are 18, right, to pass to the movies. You can make another attribute. Okay. Thank you. You were saying that this system protects the user from disclosure of information that's not needed to provide services. So the movie theater says, I need your age, and I need so a picture from your passport. So here's a stupid example, but what if at the level of this mobile application is decided, so what you give to the verifier? No. So there's a reference application. So there's a query to get the data, to get information. Policy is described. So this policy comes to us. So it's stored there and then comes so this description of the query, and so it's parsed, it's the band, and then we know what kind of attributes we need, and so the user gets human readable. So then you can read some text that says that we need to check this attribute. You need just to provide this kind of picture, and then the user decides agrees or doesn't. Okay, so there is no time left. So let's move it to offline. Okay, 3 questions, 3 minutes. Correct me if I'm wrong. That you're using certain keys that are issued and then put in the wallet. How they deliver it into the wallet? You use so set of keys. What do you mean delivered? They are delivered. Issuer creates it and sends it. The key is done in the wallet. Yeah. So he just sends some data that gets to the user, signed by the user's key and then kept locally. Yeah, so from the application, from the wallet application. So because that's what I was saying, that unfortunately with this approach we need to get into the verify user system as well, get access to these systems. My question, so there was this beautiful cat inspector, little kitten, that does audit research, including has an access to what's in the wallet. What is it? What research? What investigation does this fuzzy creature do? 40 seconds. Has no access to the user's wallets. It doesn't have an access. If you see, so this guy has an access only to the verifier. So when the check has been done, inspection transaction is there, and so with tokens of the user. So then the token by itself cannot be opened by the service, but the inspector. But the inspector may need to get accurate data, and then he using his key, he deciphers. It decrypts, so with his private key, what was encrypted in case the investigation is needed. So that's why he does not get an access to the wallet of the user, but only to the data that the service got, on the basis of which he made a decision that verification has taken place. Okay. So one last question. I understand how this mechanism works. I don't understand why do we need this middle dot. It kind of can be implemented without it. So one sends another agreed. So what's the catch? The data you have the data. Why do I have the middle? And there's no need for the middle. I can agree with another guy. So why should you be in the middle? So you in the middle. So you're the user of the wallet. It's kind of what do you mean just to agree with someone else? What do you mean by that? Okay. So sorry. I suggest we take it out for the coffee break. So next speaker, Khatyan Vladimir Pavlov in English, and that's why if anyone needs translation devices, headsets, go get them. So then, so we can always vote if you like the presentation, and then you can tell us if you want to participate at the developers seminar with the same speakers tomorrow.